Welcome to today's workshop, where you will learn how to use Hugging Face and Pinecone in real-world applications. I am Amanda Wagner. I'm the Senior Community Manager here at Pinecone. And while I assume most of us have a baseline understanding of both who Pinecone is and Hugging Face, to reiterate, Pinecone is a vector database that makes it easy to build high-performance vector search applications. Now, Gareth will, of course, add additional color to that as we go on. But before I throw it over to our fabulous host, let's do a few housekeeping. Now, I asked number one that we use the chat for chat. Feel free to introduce yourself. But as a question comes up, we do ask that you add it to the Q&A portion of the Zoom and not the chat. We will reserve roughly 15 minutes at the end of this workshop for your questions. So this just helps us, keep organized and answer as much as we possibly can. If you miss something, do not worry. We are recording this session and we'll be sharing it with you post-event. I also encourage you to follow us on social media, where we share upcoming events and past events. Now, if you have a question after the event, perhaps it's something that came up post-workshop, you can email me personally and I will serve as your inquiry liaison to our host. So you can email me at amanda@pinecone.io. Now, without further ado, I want to introduce Julien Simon, Chief Evangelist at Hugging Face. I worked on that. And Gareth Jones, PM of Relevance and Experience at Pinecone. Julien, why don't you start us off telling us a little bit about yourself and Hugging Face?
Sure. So thank you very much for inviting me today. It's a pleasure to meet all of you here. So yes, my name is Julien. I'm based outside Paris, and I'm the Chief Evangelist for Hugging Face, meaning I work on a daily basis with customers and developers to help them understand and adopt Hugging Face tools and services. So let's just jump into the presentation, if that's okay. And let me tell you a little bit about Hugging Face and why we think you should pay attention. So you should see my slides right now. And well, it's 2022. And one of the things that we see happening in machine learning and deep learning specifically is the rise of transformers. And for a couple of years, transformers have really been on everybody's radar when it comes to training deep learning models. But I think now we're actually moved up a step, and that's why I'm saying that transformers are eating deep learning now. And if we look at industry reports, like the State of AI report from last year and the Kaggle Data Science Survey from last year, we see clear statements on transformers becoming a general purpose architecture for deep learning, displacing traditional architectures like CNNs, LSTMs, RNNs, and the other ones. And not a week goes by without one of those crazy state-of-the-art transformer models breaking new state-of-the-art benchmarks and just pushing the envelope on what's possible with deep learning and transformers. And in fact, the latest State of AI report just came out a few days ago. I really encourage you to go check it out. It's a good read as always. And slide 42 of all slides tells us that there's really, again, this generalization process at work for transformers. A few years ago, you would associate transformers with natural language processing. And fair enough, that's definitely where transformers started with Google BERT and then the follow-up models. But now you can see NLP is actually less than 50% on if you look at transformer papers for 2022. Over half of the papers deal with a different modality. So from image to video to audio to multimodal to other use cases, protein folding and recommendation and whatnot. So it's very interesting to see that generalization process at work. And so what we really advocate at Hugging Face is a reinvention of deep learning. And again, I'm calling it 2.0. It might end up being 1.1, we'll see. And deep learning 2.0 is really the alignment of transformers replacing traditional architectures, transfer learning, which is gradually replacing building, curating, labeling huge data sets. And instead, we can work with off-the-shelf models, pre-trained on a ton of data, sometimes using them as is, and sometimes fine-tuning them a little bit on domain-specific data. The third planet is the rise of machine learning hardware. So of course, GPUs are still around, and that's fine. But we work with a number of companies like GraphCore, Habana, Intel, and of course, the ONNX project to build tools that leverage hardware acceleration features so that you can speed up training and inference for transformer models. And that's a big concern because as we know, these are bulky models, and we want to make them not only accurate, but also very fast. And last but not least, and I guess that's the obsession that we have at Hugging Face, we want to build developer tools. We want to build tools that everybody can use, not just the trained data scientists and the PhDs and the machine learning experts, because of course we need the experts, but we also need normal developers, and I mean that in a very benevolent way, application developers, front-end developers, mobile developers, to understand how they can easily add state-of-the-art models to their applications in a few lines of code and without having to understand the complexity in the models themselves. So, really insisting on that developer tool. And it looks like we're doing something right because Hugging Face, as you know, is stewarding open source projects like the Transformers library, which you can find on GitHub, of course. And as it happens, this project is one of the fastest growing open source projects ever. You can see on this slide the graph of GitHub stars, which I'm sure you're familiar with. It's a measure of popularity for open source projects. And Hugging Face is the blue line on the left with the small starship. And it has the steepest slope, meaning we're just growing faster in popularity than pretty much everything else right now, including amazing, reference projects like PyTorch and Keras and other ones. We're even growing faster than Kubernetes, which I think is mind-boggling, given the ubiquity of Kubernetes in IT right now. And that translates into, on top of the open source libraries, the Hugging Face Hub, which is our web site, our huggingface.co. People call it the GitHub of machine learning. I think it's a fair analogy because that's really where the machine learning community, from individual developers to large organizations like Meta and Google and Microsoft and others, go and share their machine learning models and data sets, right? So just like on GitHub, you would find code and share code. Well, you go to Hugging Face to find models and data sets and share yours as well. We have a fast-growing collection of models. This slide is always outdated. It looks like today we're extremely close to 80,000 models, 12,000 data sets, and over 100,000 users using the website to, again, share and grab artifacts. And just to give you a sense of the scale, we have way more than 1 million model downloads every day. So very proud of this adoption, and we thank everybody for using the hub and the models, and keep doing it, right? If you've never seen Hugging Face, this is a simple example. So in this example, I'm classifying text using a model from Facebook. And even if you've never worked with Hugging Face, and I guess even if you don't even know Python, you can figure out what's going on here. I'm importing the pipeline object from the Transformers library. I'm building a zero-shot classification pipeline using a Facebook model, passing it a bit of text. This is actually from Wikipedia. And then I'm defining some labels that I want to score that text on. And then I get a result just like that, right? So those 4 lines of Python just let me predict what this text is about, passing arbitrary labels, right? And I didn't train anything, and I didn't write any machine learning code. So that's kind of the NLP starting point for Hugging Face. But if we want to go a little bit crazy, it's not our topic today, but I want to show you the breadth and depth of models that are available today. I'm sure you've seen those crazy image diffusion models where you pass a description, a text description, and you generate an image from it. And this is using another one of our open source library called diffusers. The code is equally simple. And this is the image that I generated actually this morning, just passing this text description to that stable diffusion model. And this is really amazing. And generative AI is really on the roll right now. It's literally improving every day. So all those models are off the shelf on Hugging Face. You can grab them. You see the code is simple, and you can get started in minutes. Before we jump into the demo, when we talk about how Pinecone is using Hugging Face and inference endpoints, here's the family picture of Hugging Face. So on the right-hand side, of course, data sets and models, and then starting from those, you can train them using either our transformers library or the accelerate library, which is a good library for distributed training, multi-GPU, multi-TPU, etc. You can use AutoML with AutoTrain. You can use Optimum for hardware acceleration on training and inference. And then, of course, you can use our super popular Spaces service to deploy those models in simple web applications that are hosted on Hugging Face. And in order to showcase your models either to your stakeholders or to the community. And again, if you've been playing with those stable diffusion models lately, maybe you've been using a Hugging Face space without knowing it. But when it comes to deploying models and doing actual production work, of course, you could grab those models and deploy them anywhere, build your containers, et cetera, or you could use our latest and greatest service, which is what Pinecone will tell you about in a minute, called Inference Endpoints. And Inference Endpoints, in a nutshell, is a managed service that lets you deploy pretty much any model from the Hugging Face hub in a couple of clicks to manage scalable infrastructure, either on AWS or on Azure. Okay, and it comes with auto scaling and all the security and compliance that you might want. But Gareth will tell us about that. The last thing I want to call out is we also have cloud partnerships. So you can also directly deploy models from the hub using Amazon SageMaker on AWS or on Azure using Hugging Face endpoints. So you can train and deploy the models. But I guess that's the topic for another day. Today, we want to focus on inference. And I think it's time to have Gareth, of course, introduce himself first of all, and then tell us about Pinecone and how Pinecone has been using inference endpoints to build really, really amazing applications. So let me give the screen back to Gareth, and can't wait to hear the story.
Great. Okay. Yes, thank you everybody for joining. I'm Gareth. I'm a product manager here at Pinecone. Previously, I worked as a machine learning engineer, working on computer vision, NLP tasks, just like all around data science. The teams that I'm responsible for are kind of our experience and relevance. How can we basically deliver an easier way for people to get started with applications like semantic search, question answering, multimodal image to text search, many of the things that actually Julien was talking about can be powered with vector search. So today I'm going to be going through kind of what semantic search is, and then how you can use Hugging Face, and particularly Hugging Face inference endpoints, to deploy these services with Pinecone very easily. And we'll end with a short demo of a collab notebook showing how you can actually do this kind of end-to-end in a couple of minutes. So with that, what is semantic search? So I think many people here are familiar with text search. We use it every day with Google. or any kind of number of applications. But the way those systems traditionally have worked is more keyword based. They take your individual words and they match it against words they find in documents. So you'll search something like bank, but we all know that bank can mean, many different things. It's an action a plane does, there's a feature in nature, or there's a bank, like the Bank of England. Now, if you were to think about semantically, what those words mean, they're completely different. And semantic search is about trying to basically take advantage of the fact that you want to do more than keyword search. You want to understand what people are actually saying or asking for, or what documents are talking about. So here, these two sentences, for example, are extremely similar, even though the text is completely different. While these are completely different meanings, even though they use the same word. And that's where semantic search and transformers really come in to play. So how does one actually do this? Well, in a kind of early set of breakthroughs a few years ago, people applied the technique of transformers to basically revolutionize the way that search works. And this, technique is so effective that it actually is now used to power, search across Google, Microsoft, everywhere, kind of in a short number of time. Just as we're seeing generative AI rapidly increase, semantic search and search techniques using embeddings have done the exact same thing. So what happens is, you'll have context, like a document. Maybe it's a web page, maybe it's an image, maybe it's kind of just any piece of data that you think people are looking over. And then there's this query. Now, both of these, query and context, are encoded into a single vector space. This vector space is high dimensional. In this case, we're just showing it in 2D, but oftentimes it's hundreds of dimensions. And the nearness of these 2 points in space captures how semantically similar the two objects are. So if I were to query, I'm basically going to be going and looking for vectors, these document vectors, in this large high dimensional vector space that are most similar. And that's how I'm going to return kind of the documents or scores to users. So how does this actually happen? We're talking a lot of data here. Maybe you have millions of documents or hundreds of millions of images. Or you're Google. You're talking. The entire internet needs to be encoded as vectors, and you need to do that in a scalable fashion. So you have two different kind of key components to any semantic search system. You have one, the embedding models. Take your Hugging Face model. That's over here. And then you have a vector database. A vector database is the kind of search engine that powers this vector similarity search that you saw above. It's really critical that it runs efficiently. It can support all sorts of things like filtering and updates and kind of all the things you would maybe normally expect from a traditional database. But it's really that both of these things are running in tandem. You can't really have one without the other. Hence why we think it's so important that Hugging Face and Pinecone are working together. They're both huge problems on their own. They all have, all these intricate little pieces that need to be solved and have amazing developer experiences. And together, that's where we think our two solutions really shine. So how do you actually do this? What does it actually look like? In a particular vector database, rather than scanning over every single vector, if you have 100 million vectors, how can you compare this query vector to 100 million vectors? Well, you actually do it by limiting the search rather dramatically. And this is where we use popular algorithms and algorithms we've actually developed on our own to make that a scalable process for people. Because you really, when you're building a search application, want to support low latency responses. And this is a big problem when you're searching over millions of documents with embeddings. And so this is that approximate versus exhaustive. As you kind of grow your data set, in some cases, we're talking hundreds of millions or billions of vectors or documents that are represented. How do you kind of maintain that latency and performance in a way that isn't linear or is very much sublinear with the amount of data you have? And that's where Pinecone as a product is just the simplest, most effective way to get this kind of performance from your vector search applications. So, how does Pinecone fit in with Hugging Face and the rest of the environment? This is a pretty standard setup for semantic search, right? You're going to have your documents. You're going to have users who are performing queries. You know, this query might be actually something like a chatbot interface. It's not necessarily like a search bar. A user is providing you some data, and the Hugging Face model, the transformer, needs to be deployed to support both this batch transformation, like basically turning your documents into data that is stored, embeddings that are stored in Pinecone, but then also in real time, because those user queries actually need to be transformed into embeddings, sent to Pinecone, the results returned and back to the user in a short period of time. And this is where managing a vector database can become quite challenging, because the model and the database both need to be live pieces of infrastructure. And most teams that are actually working with Pinecone are more machine learning teams, right? They're people who are focused on building better models, putting ML into production. I think Julien made a great point about you want simple and accessible tools that make it so that whoever you are, you can actually build an application with this thing. You don't need to be an expert in vector databases. You don't need to be an expert in, you know, writing TensorFlow to build a model or to train it. This is a thing that, you know, we've learned and Hugging Face has learned how to do exceptionally well. And that's kind of our goal with Pinecone, is that this should be an extremely simple interface for people to get started building these services, and the Hugging Face Inference Endpoints are just one extra way to help you move these systems into production even faster, regardless of your level of expertise in machine learning. So when I say simple, just like how simple is Pinecone to use? You know, I think Hugging Face really leads the way on, like, you know, hide all the gross details that are not important for most people. You can actually go and create an account on Pinecone today. A free account. We offer an unlimited free tier for you to use. And this is roughly exactly what a code snippet would look like for you to set up a new index to perform semantic search, right? You're going to initialize a Python client that connects to your account. You're going to be able to, in one line, create an index, like select that index, upsert vectors, and query with new vectors, like new queries from users. So it's very, very simple to get started with. One extra added benefit of Pinecone, particularly in comparison to other vector databases, is that it's near instant refresh. I think most people are familiar using a database, and Pinecone works a lot like a database, where you can create new vectors, you can update them, you can delete them, all in real time. This makes it a lot easier to get started with and build a wide range of applications, from semantic search, chatbot, multilingual, recommendation engines, etc. And Pinecone also offers really great functionality around filtering. We see a lot of use cases where users are, they don't just want to do vector search. They want to combine vector search with filters. You know, I want to search over only English documents, or I want to search over documents from one department, or this user I know is asking a question about, you know, a particular product or something like that. This gives you some of the really great functionality that we're used to with search and databases, but combines it with the new state-of-the-art techniques that come with vector search. So with that, I'm actually going to go through a quick demo on how to actually build a kind of end-to-end pipeline for vector search with both Pinecone and Hugging Face inference endpoints. Okay. Share the screen. Great. All good, I assume. So here is a notebook. You can actually find this exact notebook in our documentation section under integrations and Hugging Face on the Pinecone website. But here what we're going to do is we're going to build a semantic search pipeline for working with the SNLI dataset, which is kind of a series of kind of propositions and answers. To do this, right, we're going to set up a Hugging Face inference endpoint and a Pinecone index. So to actually go and create a new inference endpoint, I'm going to go to Hugging Face, the inference endpoints side of things, and go and create new endpoint. What this is going to do is kind of give me a bunch of configuration that I'm going to need to actually set up and deploy a scalable ML model. So here we're actually going to be working with the sentence transformer model. We are going to do the MPN, MPNet base v2 model. The great thing here is that any model that's currently available on Hugging Face, you can go and deploy, and they have the most complete set of semantic search models available today. And I'm just going to give my this endpoint a name, demo, and then because I can now choose a cloud provider in a region, and I'm in the United States here in New York, so I'm definitely going to want something in the US East. And
Gareth,
here,
sorry to
yeah.
interrupt. Can you maybe zoom in a little bit in your browser?
Oh yeah, definitely. Yeah.
Because I'm guessing I'm not the only one with glasses out there. Okay,
No,
that's
you're
much
good.
better.
Is that better?
Thank you.
Thank you so
Sorry
much.
for the interruption.
No. Great call out. So yeah, here I'm actually going to be configuring this inference endpoint. All right, I'm going to choose AWS, Northeast Virginia. Here under advanced configuration, you're actually able to select which type of machine that we want to use. So, there's a whole range of both CPU and GPU machines. For a system that requires low latency, you're going to want to choose a GPU, right? Fastest turnaround time. In some cases, it may be okay to just have a more cost-effective solution where all you need is CPU because it runs in the background. I could actually auto scale this. So if you know that you have customer traffic that varies significantly, which is a use case we see with Pinecone, that there are some times of the day where you have tons of users, and at night in the United States, nobody is on it. This will give you that opportunity to actually scale up and down without having to take any action yourself. It'll just look at the query throughput, and to meet the sort of spec that's required, scale up as necessary. Now the task is really important, right? For semantic search, we're actually going to choose the sentence embeddings endpoint. This is going to say that when we send text to Hugging Face, we're going to get these numerical embeddings back. And then here, we just have the opportunity to choose our particular framework. You're almost always going to be wanted to be protected. This will require an API key, but you can obviously provide no authentication or private endpoints if you need to use something with AWS for a private link.
And yeah,
which
if I may
level.
jump in just for a second, this is actually very important because model deployment involves typically all kinds of plumbing, building containers, having a model server, et cetera, et cetera. And one thing that's really tricky to get right is security. And public here means public. It means it's open to the internet and no authentication. And I'm guessing most of the time it's not what you want. So protected means you use your Hugging Face API token for this. So it's still open to the internet, but with authentication. And private is actually a very interesting setup where the model, the endpoint is deployed in a private subnet. It's still in a Hugging Face account. And you can connect it to one of your AWS accounts through AWS Private Link, which is an AWS service that lets you connect two accounts privately without going through the public internet. So if you need strong security and compliance, and I'm guessing a lot of customers want that, private is really what you want to do here. And the setup is very easy, even if you've never used Private Link, no worries there. So just saying, this is not strictly always open to the world. You can lock it down, make it very, very secure and compliant. We have customers using this for HIPAA applications, et cetera, et cetera. So very, very important to get your security right. Okay.
Yes, no,
tell us more,
security,
Gareth.
security is super important and definitely worth calling out for Pinecone as well as a database, right? Your data is extremely secure. We're also SOC 2 compliant as well. So here you can see I've got this new endpoint actually initializing, but I already have two deployed. And to this point, these are on public, so they don't require authentication. So I will be turning them off later, but you can actually see in here, we can actually get the number of requests and analytics about the particular use case. But for now, what I'm going to actually want to do is copy this endpoint URL, because now we actually have the endpoint that we're going to use for our particular application. So here, I'm going to put that in there. This is public, but if I need to get an API key, what I'm able to do is just go into my Hugging Face account settings. So here, I'm going to go, I'm in my Pinecone organization. I go to organization settings, I go to API token, I copy it, and I actually put it in here. And now I'll be authenticated to this particular service. Now, all I need to do is make a single REST call to actually go and invoke the service. So here I have
Can you
returned
zoom
my,
in? Can you zoom in as
Yep.
well, please, Gareth? Sorry
Yep,
to.
perfect. No, you're good.
Thank you. Yeah.
And so here I made I had two sentences that I wanted to get embedded, turn into embeddings. All I had to do was call out to my Hugging Face endpoint that I defined up here, and I get these embeddings back with a dimension of 768. Now for this example, we're going to be using the SNLI data set to kind of look at what a typical semantic search application might look like. And this data set actually has, I think hundreds of thousands of passages, but we're only going to work with the first 5,000 just as a kind of get a sense of how this works. Now I'm actually going to go to Pinecone and create an account here. So zooming in. So I'm going to log in. And I'm actually having an account in the free tier. So this will be exactly what it looks like if you are doing something yourself. So I have my default project. I can now create an index. I'm going to call this semantic search. And remember, my embedding model has a dimension of 768. So I'm going to put that in there. We're going to use similarity as our cosine metric to compare two pieces of text, the queries and the documents. And then I can choose a different pod type. Pinecone offers a few different kind of choices for pod types, whether or not you need cost-effective storage or super low latency and performance. So this is going to be our cost-effective pod type. And yeah, I can now go and create this index. I'm now going to be able to take this name, this index name, go to Pinecone, hold on. And I'm going to need an API key. So I'm going to go to API keys. I'm going to copy this value, go back to Pinecone. I'm going to enter my API key. And then I have the name for my index, which I already have in here. Let's see if it's here. And so now I've been able to successfully connect to my index. I can confirm the dimensions are correct. And now I'm actually just going to go and upsert these embeddings using the Hugging Face Inference Endpoint. So this is running on GPU, not super optimized, but we're just going to upload the first 5,000 pieces of text to Pinecone. You can actually do this sort of implementation asynchronously and kind of achieve like really massive throughput upserting. But as this is running, I'll actually run through a little bit about what's going on here. So here, we're taking each document from that SNLI data set. We're actually batching them together to improve our performance. We're sending these documents to the Hugging Face Inference Endpoint. We're then getting the embeddings back. And here we're actually storing the text as metadata. So we're pulling out the text that will go with each document, assigning an ID. Every document in Pinecone needs a primary key and an embedding, a vector. And then we're actually just kind of zipping the metadata and the embeddings and the IDs together and upserting them to Pinecone in real time. So as these are getting added, they're becoming instantly available for indexing. And then now that the indexing is nearly complete, we will have, we're going to take a few example pieces of data, a few premises from this data set to actually test. And what's happening here is each kind of question we are asked, each search is one of these queries. What we're going to do is we're going to transform it into an embedding using the Hugging Face Inference Endpoint. And then we're going to return the top 5 matching documents to this particular query. So here what we can see is a person on a horse jumps over a broken down airplane, right? The semantic scores for cosine similarity vary between 0 and 1, 1 being the most similar, 0 being the least similar. And we can see actually that none of these are particularly great fits. While there is, the word air and brown horse in kind of here, it's not actually a semantic match. These actually mean completely different things. There's no similarity whatsoever. And we'd say, a similarity of 0.57, that's not very similar. We may still return this result to the user. It's still the best answer we have, but it's probably not what the person is looking for. I can run another query. A woman walking across the street eating a banana while a man is following with a briefcase. again, we can see that the semantic search kind of pulls out that there's a man and woman walking together. There's another similar one, which is people walking, but it still doesn't actually capture the kind of concrete meaning of the sentence. And then maybe one more example that we have is people on bicycles waiting at an intersection. Here we can actually see people riding bikes, that the performance is just slightly better. We're getting more certainty. And in many cases, if you have a large vector database, you have lots of documents that basically this will relate to, you'll expect to see kind of cosine similarity scores, in the kind of like upper like 0.8, 0.9 level for really strong matches. So one really, great part about this is that these Hugging Face models will perform pretty well across these domains. We find users who are taking open source models and in their very first iteration of building a semantic search application, not need to do any fine tuning or kind of additional training, but many users will actually work once they have data to build their own models that will perform even better for their data domain. And in fact, Pinecone is going to be releasing a new type of index that'll allow you to kind of merge both the keyword style search and the semantic search to get even better results when you don't have a fully trained model. And you can look forward to hearing more about that in the coming few weeks. But yeah, this is kind of an end-to-end example on how to build your very first semantic search application, whether it be for chatbots, whether it be for web search or code search, anything like that. Yeah, and then afterwards, all I have to do is I can delete this index and clean it up. With that, I think we can go back to answering some questions about Hugging Face, about Pinecone, how to build semantic search, and things like that.
Yes, we can. And we've had a few questions come in. And that doesn't mean you need to stop. Feel free to continue asking questions. We'll cover as many as we can. First question from the Q&A, and there's a few follow-ups here. So we have data in Elasticsearch DB running on premises AWS private VPC. How can we use Pinecone to augment our keyword search with semantic search over the documents that we have in the Elasticsearch DB? Yeah.
So a question for Pinecone, I guess. So the answer is, if your Pinecone can deploy in AWS, and depending on some security requirements, you can also get a more dedicated environment. What you're likely going to want to do if you already have Elasticsearch and you're not ready to move to a full semantic search application is do sort of, what we would call like this hybrid Elastic plus vector search solution. So you'll likely take the queries that are being run against your Elasticsearch cluster and actually take those queries, run them through a Hugging Face transformer. So you get the embedding, basically fetch the results both from Pinecone and from Elasticsearch, and then use the scores from both to come up with a final ranking. We actually have some really interesting research that we'll be publishing here about how to like actually do that re-ranking. But even some like very simple tricks of saying, double the score of semantic search and half the score of Elasticsearch can give you really effective results and actually boost the performance without needing to fully replace your entire search infrastructure today.
Awesome, thank you. And I'm going to jump around because I think we have enough time to cover the majority of these. So what kind of performance metrics do you have in AWS deployed endpoints?
So yeah, I'll take that one, I guess. So we deploy on AWS or Azure. We use the instance type that you selected. You get auto scaling as Gareth mentioned, and if you go to your endpoint metrics, you can actually see 2xx. You can see HTTP status codes, so you can see 2xx. 4xx, you can see latency, etc., etc. So you get some visibility on how the model is performing.
Do you have recommended, again, jumping around, Hugging Face models to use for embedding English and multilingual?
So I guess sentence transformers is the best place to start. You know, you could use any model that starts from any NLP model that starts from a text string and spits out a high dimension vector. But you know, sentence transformers are specifically built for that. You know, fine-tuned, and the sentence transformers library is extremely easy to use as well. So I would start from there, and you know, if you don't get the performance that you need, then you could, as Gareth mentioned, you can fine tune on a little bit of data. If you have extremely domain specific data, I don't know, chemical
Yeah.
engineering or something, and you want to squeeze out extra accuracy, then you can go and fine tune the models a little bit more. Yeah, so sentence transformers, best place to start. I don't
Yeah,
know,
I
Gareth,
think
if you wanted to add something
I,
there.
yeah, I think what we've seen that are particularly effective, and I'm trying to find the particular link, the actual sentence transformers documentation page goes through kind of a ranking of very popular models that are in the library today, all of which are available on Hugging Face. And maybe Craig is able to find that link for me. I think we chatted about it very recently. I think there's the mini LM model, which is a very performant at like price to performance sort of thing. It'll run very fast. I think the MPN net all model is also quite performance as well. And then if you really want to go for it, I'm sure like you can take the embeddings from Bloom. You can go all the way up to the largest thing. But I think what we found is that most people are able to get very good benefits from even these smaller models that have been kind of compressed or distilled without losing a lot of
Start
performance.
small is
Yeah.
always good advice. Okay,
Yeah.
so I know it's very tempting to go the latest and greatest and fattest model out there, but chances are you'll probably make your life more complicated than it needs to be. So yes, mini LM and those are really great. Start
Yeah.
there, run your tests, measure your your metrics, and if it's not good enough, then at least you know what the baseline is, and you know how much bigger the models need to get. But if you start too big, maybe you get good accuracy, but maybe it's just a waste of compute resources, and you don't want
Yeah.
to do that.
Yeah. Greg actually dropped into the chat for the session, kind of the suggested sentence
Yeah.
transformer models with their kind of, I think, speed and performance. So that's a great place to start, I would say.
Great, thank you guys. So when does the database get updated when you do not have embeddings for certain word examples?
Yeah, so this is sort of out of domain problems. This is where I would say we're very interested in newer techniques that are appearing. Again, we're going to be offering something called a hybrid search here in a couple of weeks, and what that'll do is actually kind of mix the token based. As you imagine, like keyword search doesn't require a lot of training, at least the very naive version of it. And so what we found is that if you do this kind of re-ranking, or you do this kind of combined scoring over the tokens, the free word frequencies, it performs extremely well, especially on rare phrases. While semantic search performs extremely well over like context and what the larger meaning is. So merging these two results gets you very incredible performance without fine tuning. I think when it comes to actually doing fine tuning, there's techniques like GPL and others that can help actually kind of fill in the gap. But those are often like a little more complicated and sophisticated. And many people, depending on how far away they are from a target domain, may not need to actually go there.
Great. I'm loving these questions. You guys are still pouring them in, and I appreciate it. How fast is the auto scale? So I think this
So
pertains a little bit. Yeah.
Yeah, so we rely on, of course, as you would expect, we rely on the underlying cloud auto-scaling mechanism to do that. So if it's going to be AWS autoscale or Azure autoscale, if that's the proper word for it, and that's what we use. I don't think we add anything particular on that. Again, run your load testing. It should scale. I don't think we want to discuss the implementation too much, but it should scale pretty fast. If you see something that you don't like, let me know.
Yeah, we actually did test. We were one
I'm
of the
sure you
design
did.
partners. Yeah, we were one of the design partners
Yeah.
for helping understand the app, whether or not this would be a useful thing for semantic search. So we did test the auto scaling. Right, you can imagine as somebody who's, there's kind of two workflows, common workflows. There's, batch transform. I need to turn, hundreds of thousands of documents or sentences into vectors, and I want to do this like live real time thing. We actually were able to test, and we found that the auto scaling was pretty responsive within a minute or so. And I think that's, we're talking like scaling from like 1 to like 4, right? So once
Yeah.
things were really kind of got going, once our containers are ready, we found some pretty impressive kind of scaling up and down as well. So
Sure.
we're really excited to kind of like continue to provide that feedback on like what I think semantic search use cases need or chatbots need to kind of anticipate it. You can also set like a minimum if I think, when you're going to need like a certain amount of traffic. I think you could go in and kind of anticipate that a little manually. Sometimes that's the cleanest solution
Yeah.
when you're not sure.
Yeah, I think it's it's like auto scaling can be manual, which is not
Yeah,
intuitive, but you can warm up if you expect a huge spike in traffic in the next 2 hours. I've worked with a lot of AWS customers who would actually go and manually provision a little bit more just to make sure, because if you have one sleepy instance and all of a sudden it gets, a zillion hits, there's always going to be a bit of latency. But if you know it's coming, you don't know exactly how much and you don't know exactly when, but you know it's coming, you can kind of update the configuration and warm things up a little bit more, and then let autoscale figure out if more is needed, and more importantly when less is needed, because that's when you save money, right? The worst thing is having infrastructure doing nothing and just costing you money. So scaling
yeah.
down is equally important.
Yeah, thank you. Gareth, this is for you. We kind of touched on it a little bit, but maybe there's more to double down on. Can I use Pinecone with Elasticsearch, or do I have to migrate my whole search stack to Pinecone?
Yeah, so many customers today are using Elasticsearch alongside Pinecone. It's just, sometimes it's just the way that your system is built. You've tuned your Elasticsearch cluster. You can just fork these queries to both systems and then merge the results. Like the semantic results provide distinct kind of results different from the lexical or keyword matching strategy. Where I think we're probably headed is, in my perspective, right, the big advantage that semantic search offers, and just the technique of using embeddings, is very similar to, I think, just like deep learning as a whole. I think if you were to go back only 5 or 6 years, right, the whole world was building computer vision systems with manually engineered features, where you're like, is this an edge, or is this a face, or is this a pair of eyes, and then classifying it that way. Deep learning basically revolutionized the whole field and said, you're just going to use training data. You're going to use machine learning to actually construct a model that understands everything more than you could ever define as a person. And I think that's where we see this shift from kind of Elasticsearch, which is like keyword matching, very feature engineering like, to kind of fully learned search and retrieval systems, where you can just through training data and through models encode things and concepts that you would never be able to engineer manually. So I think what I would say is, like, yes, in the short term, probably use both if that's how your system needs to operate. But we're very confident that eventually, a lot of search will move towards vector or systems that are jointly powered by vector and maybe other methods too.
Great. We had a question that I believe was answered by a friend in the chat, but perhaps you guys can add additional thoughts. Is query latency in milliseconds or seconds?
Milliseconds. Yeah, I think there's most products, most people need that sort of latency. We offer kind of a series of trade-offs, just like I think Hugging Face does with the different types of CPU versus GPU and certain sizes. We also offer that side, kind of like sliding scale at Pinecone. And so that's why together it's a very great kind of managed service, in the sense that you can kind of choose those operating points based on your needs and your costs. I think there's a great point of like, you don't need to make the system over provisioned and expensive. If you don't need 10 millisecond, 20 millisecond latency, or if you can have 100 milliseconds, right? You can just operate a lot more
dev
cheaply.
and test, it's again, sometimes I see people going default on like large GPU instances, and fine. I mean, if you have the budget for it, why not? But I think it's a shame. I think you need to be frugal and conservative, and it's important that that when you do need the firepower, so to speak, it's gonna be there. But if it's just testing, just save money, right? Save money, save and save resources. I cannot, I'll keep repeating it. I think it's just a good practice.
Yeah, and speaking from my own sort of time as a machine learning engineer, at one point we had a company I worked at with a small team, 5 machine learning engineers and 3 other kind of infrastructure people working with us, had more than 20 live deep learning models, like separate models, not replicas, like running at once, and that was very expensive. I have to tell you, once you get to that kind of scale, you're talking, tens of thousands of dollars a month to just run computer vision. And it was a big pressure for us. Like, how do we build models? Build fewer models? Can we combine? Can we have a model that is multi-headed, can like solve 3 problems at once? It also just becomes like complex, right? The fewer kind of things, the more budget you buy yourself time-wise, the easier it is for you as a machine learning engineer and as a system to actually maintain something. So I don't want to say like set your expectations low, like say, it's always about like.
I think when you start doing ML at scale in prod, you sometimes you're surprised how much money you spend on inference. Everybody's so obsessed with training because we tend to use large GPU machines to do that, and they have this high cost per hour. But we train for a few hours, maybe a little more, and then we're done, right? And then we go and deploy the models, and they stay up 24/7 for forever, right? Connected to your business applications, and they scale up and down. And if you're successful and have a lot of traffic, that stuff adds up. So maybe even if you're using smaller instances for inference than you're using for training, the costs do add up. And that's why we paid a lot of attention to the scaling mechanism and to the cost efficiency of inference endpoints, giving you lots of options, including very, very inexpensive ones, because we know for a lot of companies it will add up. And when the AWS bill or the Azure bill comes at the end of the month, it's like, oh man, are we spending that much on endpoints? And yes, we are. So we want to save you from that bad surprise at the end of the month. So be conservative, use auto scaling to the max and start small.
Yeah.
Switching gears slightly to security, can you ensure data privacy? Who has access to the vector database, the query sent for getting the embeddings? And then there's a thanks, which I'm always going to shout out politeness.
There we go. So yes, from the security standpoint, the data is it's a cloud hosted product, but we're kind of taking all of the kind of measures, like your data is not accessible to any other users. Your data is all extremely separated and secure in that sense. For some people who do require extreme levels of security, we have provisioned people their own kind of environments, but we found that kind of regardless of the application, our kind of security practices, both like in how we operate as a company and how we think about users' data, our customers' data, how we think as people, and we make many decisions to ensure that both in how things are technically architected and how we do our work, that's never a threat. That your data should never become kind of available to anyone at Pinecone unnecessarily, and definitely not to any other customer or the outside world as well. I think if you have more precise or specific security questions and are interested as a customer, we can go through that in more detail. So I don't want to misrepresent any really specific details there.
And when it comes to endpoints, because of course we're showing both today. It's pretty simple. The service is SOC 2 compliant. Again, we build on top of pretty secure clouds, and we don't log anything. We don't log any data. We don't save any data. So anything you send is just is just stored in memory and predicted in flight, and that's it. So no one would want their data to be stored somewhere, and there's no reason to do it anyway. So why would we, right?
Fair. So how/when does the updatation of vector index take place?
How do we update the index? Is that what you're saying?
Yeah, I believe that's what we're getting at. Feel free to add additional color in the chat, Anonymous, if you have further clarity.
Yeah, so I mean, I can just talk about kind of in-place updates. Like some databases or some ways of hosting vectors are kind of more static, right? Where you build an index kind of in advance. The way we've designed our algorithms is to support very much like create, read, update sort of style of interaction, without trying to sacrifice as much, try to sacrifice as little performance as possible to get you that functionality. So we actually use a bunch of different algorithms to behind the scenes to help perform this operation. Our different pod types use slightly different approaches, use slightly different resources to kind of achieve that updating, right? So you can actually update vectors in place, or update the metadata associated with them. You can delete the vectors, kind of all the things you would expect to be able to do. I think one challenge that customers often face with vector embeddings is that whenever you train a brand new model, you kind of need to rebuild your vector index from scratch. Like two embeddings are not aligned, even if they're trained on the same data. They're oftentimes just like completely different, and that is a really interesting challenge. We don't have a way to kind of do that in place. You would need to reconstruct your index from scratch all over again. Although we are making that much easier. We are supporting like more kind of bulk ingestion features that'll make that straightforward. I think Hugging Face combined with tools like Sparks and Databricks makes it very easy to actually perform some of these like big batch computation jobs should it be necessary. But yeah, hopefully we'll figure out on the research side how to do multi-model embeddings in the same space, but it's definitely a very open area of research for us.
So Gareth, we have a little bit of a technical question that will be our second to last, but is there a way to use Python Pinecone client without relying on the global singleton? The singleton API is certainly easier to get started with, makes it harder to integrate into more mature code base. For example, integration and unit testing is harder. User multi-tenancy is harder, etc. Falling back to the HTTP API is the only workaround I'm aware of so far. And feel free to, that it's in the Q&A if you want to look at that.
Yeah. No, I understand the issue. It's definitely on the more technical side for people, but it definitely impacts your performance with the system, right? You have one Python client. It's handling those. I was talking with one of our engineers literally 2 days ago about this on Tuesday. So we are hoping to provide some more guides on how to use that correctly. If you follow up with us directly or through support, I'm happy to like sit down with one of our engineers and show you how to do that performance improvement. We've also talked about making our Python client use async IO and other techniques like that, more async native. We do suggest using the gRPC client wherever possible to improve performance further. gRPC, thanks Google. While it's confusing, it is very performant and very fast. So yes. Thank you. Good question. Very, very technical though, but very good.
Great. And then we had somebody a little bit curious if we have any research links or blogs related to the hybrid search you discussed earlier.
I'm going to ask you to wait till the end of the month. It will be coming soon. And so sign up to our mailing list. We'll be super excited to share that in due time, but can't leak, I guess.
Yeah.
No leaks.
Living and breathing in that world, I feel like, for the last few weeks. Okay, well, we're at time. I want to give both of you, first of all, thank you for attending this webinar and sharing your wisdom and experience. Any last words from either of you that you want to impart on our remaining participants?
Well, again, I would encourage everybody to try the endpoints. I think we saw a really excellent use case with Pinecone today. It just makes it simpler to build the end-to-end application. I don't want to hear about embeddings. As a developer, I have my text data and I have my queries, and I want to match both, right? So I think now if we combine endpoints and Pinecone, we're really one step closer to having this simpler reality, and that's great. And generally, it's what Hugging Face is trying to achieve: build tools that simplify the end-to-end machine learning workflow. And again, I think endpoints is doing that without sacrificing performance and security, which unfortunately some other services seem to be doing. So try it out. And if you have questions, if you have feedback, get in touch. I'm very easy to find out there. And I would love to hear what you tried and what you liked and what you didn't like. Okay. And thank you again, Pinecone Friends, for inviting me today. Really enjoyed it.
Yeah, likewise. I mean, I think we're super excited about this space working and embeddings in this technique, whether it be for low shot classification, whether it be for search, for chatbots. We think has just so much promise. And as a partner, I don't think we could imagine somebody who shares the same values around building developer friendly and useful tools. So yeah, please reach out with questions, feedback anytime. We love talking to developers and anyone building. So yeah, thank you.
Hear, hear. Okay, bye everybody. Have a good one.